Just a total of 8 kilobytes of RAM made history. In 1969, NASA's Apollo 11 mission to the Moon represented a monumental leap in human endeavor, heavily reliant on a sophisticated, for its time, computing infrastructure. The primary onboard computer was the Apollo Guidance Computer, AGC, a marvel of engineering that served as the mission's brain. Its objectives were multifaceted: to control the spacecraft's navigation, guidance, and engine firings, ensuring precise trajectory corrections for translunar injection, lunar orbit insertion, and the critical descent to the lunar surface. Support for the AGC came from a vast network of ground-based computers at Mission Control in Houston. These mainframe systems performed complex calculations, tracked the spacecraft's position, and provided real-time data to the astronauts, acting as a redundant and more powerful backup to the AGC. The guidance system, both on board and on the ground, worked in concert to maintain the spacecraft's desired path, constantly updating based on sensor readings and pre-programmed flight plans. The AGC's ability to process real-time data and execute complex algorithms was paramount to the mission's success, a testament to the innovative spirit that defined the space race. Their objectives. NASA's 1969 Apollo 11 mission had the primary objective of landing humans on the Moon and returning them safely to Earth. This ambitious goal encompassed several critical sub-objectives, including conducting scientific experiments on the lunar surface, collecting lunar samples, and evaluating human performance in a lunar environment. To achieve these objectives, NASA required extensive support, including a vast network of engineers, scientists, and technicians working in mission control and at various research facilities. Guidance for the mission was provided by the Apollo Guidance Computer, AGC, on board the spacecraft and a team of flight controllers on the ground. The AGC controlled the spacecraft's navigation, trajectory, and engine firings, while the ground team monitored the spacecraft systems, provided real-time updates, and made critical decisions during the flight. This combination of onboard and ground-based guidance systems ensured the mission's precision and safety. The mission also relied on robust communication systems, tracking networks, and recovery teams to ensure a successful outcome. NASA's computers and network for the Moon mission. For the 1969 Apollo 11 mission, the onboard Apollo Guidance Computer, AGC, was a groundbreaking piece of technology, though vastly different from modern systems. Its processor was a custom-designed, highly integrated circuit built from NOR gates, operating at a clock speed of just over 2 MHz. This was a relatively slow processor by today's standards, but incredibly powerful for its time, capable of executing complex instructions crucial for navigation and control. RAM, or rather its equivalent, in the AGC, was limited. It utilized 2048 words, 2K, of erasable magnetic core memory for temporary data storage and calculations. Essentially it's RAM. This type of memory allows for read and write operations, vital for real-time computations. For permanent program storage, the AGC relied on rope memory, a form of read-only memory, ROM, that was literally hand-woven with wires to represent binary data. This meant the flight software was hardwired and couldn't be changed after manufacturing. Traditional hard disk drives, HDDs, as we know them today, did not exist in the Apollo computers. All data storage was handled by core memory or ROM. The ground support systems, however, utilized much larger mainframe computers with more substantial memory and primitive forms of magnetic tape and drum storage for their extensive calculations and data archiving. While the AGC itself had only about 4 kilobytes of RAM, the BBC. A huge difference in technology between now and then, but NASA did manage to conduct its Moon mission. In 1969, NASA's Apollo Guidance Computer, AGC, was a marvel of engineering, a bespoke system designed for a singular, critical purpose: guiding astronauts to the Moon and back. It boasted a processing speed of approximately 2.048 MHz, 4 kilobytes of RAM, and 72 kilobytes of ROM. By today's standards, these specifications are dwarfed by even the most basic modern devices. A typical smartphone, for example, possesses processing speeds exceeding 2 GHz with multi-core processors, several gigabytes of RAM, and hundreds of gigabytes of storage. This means a modern smartphone has more than 1 million times the processing power and memory of the AGC. The AGC's interface was rudimentary, relying on numerical codes for commands. In contrast, modern devices offer intuitive graphical interfaces, touchscreens, and voice control. The AGC weighed approximately 70 pounds, while a smartphone weighs a mere few ounces, showcasing the incredible miniaturization achieved in the last half-century. Despite these limitations, the AGC performed flawlessly, enabling humanity's first steps on the moon. This achievement underscores the ingenuity of the engineers and programmers who maximized the available technology. The Apollo missions demonstrate that even with comparatively limited computing power, focused engineering and innovative software can accomplish extraordinary feats. The technological advancements since 1969 are staggering, transforming not only space exploration but also every facet of daily life, from communication and entertainment to medicine and scientific research. Please subscribe to my YouTube channel.